Hey everyone, it's Justin again. So far, we've learned how to solve singular inequalities with two variables. But what if we need to solve multiple inequalities at once? In this video, we're going to learn how to solve systems of inequalities with two or more variables. What are some solutions to this inequality? -2, 3 would be a solution, or 1, 1. Or -7, -5, or a ton of other points. What about this inequality? 2, -4 would be a solution, or 9, -3, or even 1, 1 because the line is solid. But this video isn't on solving individual inequalities, it's all about solving systems of inequalities. Here we've got both inequalities graphed at the same time. So, let me ask again. What are some solutions? Remember, solutions to a system have to satisfy every piece, not just one or the other. So the point -4, 3 would not be a solution because it isn't in the red area. And 2, -2 doesn't work because it's not in the blue area. The point 6, 4 is in both areas at the same time, so that would be a solution to the system. Here's a tough one for you. Is 8, 2 a solution to the system? It's definitely in the red area, but it's right on the edge of the blue area, so does it count? No, because the blue line is dashed. Dashed lines are not part of their solutions. What about 1, 1? It's on the edge of the red area, so is it a solution? Yes, because solid lines are a part of their solutions. As you can see, finding solutions to systems is easy with graphs, as long as you pay close attention to the overlapping areas and how the lines look. Graphs are great for finding lots of solutions quickly, but what if you don't have a graph? Well, that's easy. We do it the same way we did with systems of equations. Plug in the point into both inequalities and see if it works for both. 2 times 0 is 0, minus 3 times 1 is 3, and 0 minus 3 is -3. In the second inequality, 0 minus 1 is -1. So did the point work for both inequalities? No, it worked for the second one, but the first one gave us a false statement. -3 is not greater than 6. So because it didn't work for both inequalities, 0, 1 is not a solution to the system. Let's test 3 more points. For 5, -5, we plug in the values, then simplify. Did the point work? Yes, but just barely. If the second inequality had been less than, it wouldn't have worked, but the or equal to part saved it. So this point is a solution to the system. What about the next one, -3, -4? If you plug in -3 for x and -4 for y, here's the result. Does this point work as a solution? It does not work for the first inequality because it isn't allowed to be equal, only less. So -3, -4 is not a solution to the system. Finally, here's the work for 5, -1. Is it a solution? Both inequalities come out true, so this is a solution to the system. Like we said before, checking solutions for systems of inequalities is just like systems of equations. You plug in the values and see if everything works out correctly. There is one thing that you need to be careful of, though. Can you see the problem with this system? They don't overlap at all. Remember when we were learning about systems of equations and we found out that parallel lines don't cross, so there's no solution? Well, the same thing can happen with systems of inequalities, but with one additional requirement. These lines are parallel and they're shaded away from each other. If the lines were both shaded towards each other, like this, then there would be overlap. The same can be said if both lines were shaded up or if both lines were shaded down. The only situation in which a system of inequalities has no solution is if two lines are parallel and shaded away from each other. That's all there is to it. With the system written out, you can plug in possible solutions and see what works for the whole system. And if you have the graph, you can easily look at where the points are and see whether they fall inside all of the inequalities. In the next video, we're going to learn how to graph the systems ourselves. See you then.